Our modern world relies heavily on chemicals. They are the backbone of numerous industries and essential to our daily lives. We use them in countless products, from plastics to medicines, and even in the food we eat and the water we drink. But the production of these chemicals often comes at a cost to our planet. Pollution, deforestation, and the degradation of natural habitats are just a few of the environmental impacts. Many chemicals are derived from fossil fuels, a finite resource that pollutes our atmosphere and contributes to climate change. It is clear we need a more sustainable way to produce the chemicals we rely on. Renewable energy sources like solar and wind power offer part of the solution. This is where the remarkable world of biotechnology offers a beacon of hope. By leveraging the power of nature, we can create sustainable alternatives. Scientists are exploring innovative ways to produce chemicals from renewable sources. They are developing methods to use plants, algae, and even microorganisms. One of the most promising avenues involves harnessing the power of trees. Trees can be engineered to produce valuable chemicals, reducing our reliance on fossil fuels and helping to restore the balance of our ecosystems. Trees are nature's gift, absorbing carbon dioxide from the atmosphere and converting it into useful materials. They are a renewable resource with the potential to replace fossil fuels in chemical production. However, there is a challenge. Trees contain a substance called lignin, which gives them their strength and rigidity, but makes them difficult to break down. This is where microbes come into play. Certain microorganisms possess the remarkable ability to degrade lignin, breaking it down into simpler components. However, the efficiency of this process depends on a crucial factor: the methoxy content of lignin. Scientists have identified specific types of trees, like poplar trees, that are particularly well suited for this purpose. These trees are not only abundant, but also possess unique characteristics that make them ideal candidates for various scientific and environmental applications. Poplar trees grow quickly, require minimal pesticides, and can thrive on land unsuitable for food crops. Their rapid growth rate and adaptability to different soil conditions make them a versatile resource. Additionally, their ability to grow on marginal lands means they do not compete with food crops for valuable agricultural space. To enhance their potential, researchers have turned to a revolutionary tool in biotechnology, CRISPR technology. This cutting-edge technique allows for precise genetic modifications, opening up new possibilities for improving tree characteristics. CRISPR acts like a pair of molecular scissors, allowing scientists to precisely edit the genetic makeup of organisms. This precision enables the development of trees with desirable traits, such as increased growth rates, disease resistance, and improved biomass quality. By modifying the genes responsible for lignin production in poplar trees, scientists can reduce their lignin content and alter its composition, making them easier for microbes to break down. This genetic modification not only enhances the efficiency of biofuel production, but also contributes to more sustainable and eco-friendly practices in the industry. Section 4. Methoxy content, the key to efficient breakdown. Research has revealed that the lower the methoxy content in lignin, the more effectively microbes can break down the tree material. Methoxy groups, which are chemical structures containing carbon and hydrogen, hinder the microbe's ability to access and degrade lignin. By reducing the methoxy content, scientists can significantly enhance the efficiency of microbial fermentation. The implications of this discovery are profound. It means that by engineering trees with low lignin and low methoxy content, we can create a sustainable and efficient source of valuable chemicals. Section 5. A greener future with engineered trees. In this section, we explore the innovative use of biotechnology to create a more sustainable world. The use of microbes to break down lignin offers significant advantages over traditional chemical processes. These tiny organisms are capable of performing complex biochemical reactions that are otherwise difficult to achieve. Microbes operate at lower temperatures and pressures, reducing energy consumption and environmental impact. This not only makes the process more efficient, but also significantly lowers the carbon footprint associated with lignin degradation. Additionally, certain microorganisms can continuously produce the enzymes needed for lignin degradation, making the process more cost-effective. This continuous production capability ensures a steady supply of enzymes, enhancing the overall efficiency of the process. This breakthrough in biotechnology holds immense promise for a greener and more sustainable future. The ability to harness natural processes for industrial applications is a game changer in our quest for sustainability. By harnessing the power of trees and microbes, we can reduce our reliance on fossil fuels, create a more circular economy, and pave the way for a healthier planet for generations to come. This approach not only benefits the environment but also promotes economic growth and social well-being.